Good evening, everybody. I am Jack Long, the Mad Scientist, and tonight we are be going through basic dust collection design concepts for simple systems, 1, 2 machines, 4 machines, 6 machines, stuff like that. So this is part 1 of 5. I've broken them down into shorter videos because anybody that's watched any of my videos knows that they start out short. They always wind up turning into dissertations. So I wanted to break this up into 5 different ones. This is the first of 5. So let's get into it. Hey, good evening, everybody. Let's have a discussion here on dust collection, sizing, piping, material, some of the engineering that goes into making a dust collector work. And what we're going to do is we are going to be discussing simple systems up to, say, a 10-inch pipe, 4 or 5 machines, 6 machines, something of that nature there. If you were going to be getting into plant level systems where you're having to get into some regulations with the government and stuff like that, that's outside the scope of what we're going to discuss here. What I'm looking for to explain to you is if you're working in somewhere between a garage and, say, maybe 6 machines, 7 machines, something like that, 8 machines, maybe a planer, sander, things like that, adding that kind of level of sophistication into the system. Beyond that, the engineering to make the system work is really gets very, very complex. How you lay the lines out, where they connect, what machines are being used, when they're being used, how they're being used. There's a lot that goes into it. Okay, so what I want to do is go through a few things. I hear a lot of comments when I'm out on these social sites, and people are talking about the best systems that they can have, what they use, what they don't use. So I want to go through a couple things on the materials side of it first. First thing is that you see a lot of people, they're always talking about using PVC. That is, this is my opinion. I'm going to start a huge fight. I know I do it every time that I make comments about this, but PVC is dangerous. It holds a static charge. When the dust goes through it, it will hold a charge, and in it will release that charge at the moment that it wants to release it, which is typically when somebody touches it, and you'll get a static zap out of it. It'll shock you. And in my younger days, before I knew better, I actually used some PVC pipe on a dust collector, and when it discharged into me, it knocked me on my hindquarters and hurt, to be honest with you. I can still remember waking up, yes, because it did, it zapped me that good that I woke up with a metallic taste in my mouth. And I learned later on that taste is from the electrical shock. So anything that has that kind of a safety concern should just be eliminated, in my point of view. The other side of it and I really get a lot of armchair quarterbacks come in and beat me up over this, is that it can cause a dust explosion. And for people that want to go out and look, because they don't believe me, there's a bunch of videos about dust collectors that blow up because it gets a static discharge. And I've seen people say, oh, I wrap it with a copper line and I do this and I discharge that static. The safety issue of it is enough for me to discount using it, but there's also efficiency concerns that go with it, as far as sizing the pipe, sizing both going up and down, making your bends, the efficiency when the material goes through the bends. There's a whole bunch of things that go into it, and all in all, PVC is, in my opinion, a rookie mistake. Yes, I was a rookie, and yes, I made that mistake, and I paid for it dearly, and I wish I hadn't have, because it was an expensive endeavor that had to be changed. But I also understand the economics of it. Is when I was a woodworker and I had my cabinet shop, I did not have money. It was I was working a daytime job, washing dishes while I had my shop, and it was feast or famine. So if you're strapped for cash, I can understand the incentive to use it. Okay, so for me, I will not be talking about PVC at all. It's a big no-no, and it's a rookie mistake. Okay, so if you use it, I'm not going to shame you over it, but I'm certainly not going to compliment you on it either. Okay, this next thing is HVAC pipe. HVAC pipe it's wrong for a number of reasons. A lot of people will go into it because they can go down to the local box store and pick it up, and they can have it same day, and it's cheap, and they don't take any special tools necessarily to work with it. They seal it up and they go. The reason that it's wrong on so many levels is, for starters, HVAC is a positive system, and positive pressure system, and dust collection is a negative pressure system, meaning that there's less pressure inside the pipe than outside. Otherwise, dust collection would not work. When you work with a positive pressure system, you get thinner walls, so the pipe is significantly thinner, therefore it's less money, but it's also significantly less strong when you use it in the wrong scenario, and you use it in a negative pressure. You can actually collapse the pipe. And I've had arguments with people, and they flat out tell me 100 different ways where I'm wrong. I'm just telling you that after 37 years, I think, going on 37 years this coming January, that I've been in this industry, from a woodworker to a technician to an engineer, and I'm telling you, if you use HVAC pipe, this is what you're going to come up with. You're going to collapse your pipe at some point. The other side about it is that fittings for HVAC are not efficient for negative pressure systems. So what happens in your systems, and I'll switch over to this, which HVAC pipe and PVC both, people tend to use a lot of T's. And so when you have a T like this, and you have dust that's coming in, you have air that's coming in, and you have air that's going this way, and you have air that's coming out. What happens is this air has to go up, and then this air is coming across, and when these two mix, you got this turbulence that's in here. So if you have a sizable pipe, and you're introducing your air and you're creating this turbulence right here, you're actually reducing the CFM capacity of the pipe at this point. So the way that I would explain this to somebody, when I'm usually standing in front of them and they are questioning me, because they do question me quite a bit, why I don't like it. Think of it as you're driving your car down the road and you're doing a merge onto an interstate. When they make the interstates, they have a straight lane, and then they have a merge that comes into it, so that when the two streams of traffic are coming together, that they blend together with minimal disturbance at the blending point. Now take this scenario with a T, and you're traveling and you got a T. It is very difficult for traffic to travel at speed, make a 90-degree turn, and then come off. So what you want to do when you're coming into these pipes is you are wanting to blend your pipes in at the best angle that you can for your branches and your merges and things of that nature. And the typical angles that I see are 45s. So you got a 45 degree, and then you got 60 degree. And if I had to have my choice when I design my systems from scratch, I try to go with a 60-degree blend. And then that allows all of your merging of your dust streams and your air streams to be as even of a flow and a merge as possible. Okay? In addition to that, when you get into your elbows and you're doing HVAC, you know your elbows aren't just nice straight bends. They're sections of pipe that's put together. And each time you bend this, since it's not an even, nice, smooth transition, even flow through there, you get turbulence here. You get turbulence here. You get turbulence here. You get turbulence here. Every time you add turbulence into your system, you reduce the efficiency of that pipe significantly. Now, from the engineering standpoint, I can't tell you that it's 5%, 10%, 15%, whatever that is, but I can tell you in these, it's significant. And the reason I can't tell you numbers in this is because I don't use it and I don't bother to learn it because it's wrong. Again, going back into this, looking from an economic standpoint, if this is what you can afford, this is better than PVC. It's not great, but it's better than PVC. Looking at it from a standpoint with PVC, and you're coming back into it, when you come into your PVC, you'll notice all your angles on your PVCs are all nice sharp bends. This angle, when you're traveling with your dust collection going through here, is going to knock off the efficiency in your CFM as your material is going through the pipe. So again, it's another no-no for PVC, okay? In addition to that, when we start talking about reductions in pipe sizes, PVCs have, plastic piping has a lot of restrictions in it as far as what sizes they are when you're increasing your pipe, you're decreasing your pipe, things of that nature. Okay, so again, PVC, huge, huge, huge no-no. If I was extremely budget-minded, yes, I would do it. Fortunately, I'm no longer in that scenario. So, as we're going through this explanation, I need you to keep in mind that from my point of view, I don't care about money. I do things right, and if the customer wants to do it that way, great. If they don't want to do it that way, they can either hire somebody else to do it, or we'll find a workaround until they can justify the expenditure to do it my way. Now, I'm not saying I'm right all the time because I am human and I've been wrong more than I have been right, which is why I can tell you now from my experience what not to do, because I've made those mistakes. I've paid for those mistakes. I have replaced those mistakes. And like everything else, you'll learn more from making a mistake than doing it right the first time. So let me back up here just a little bit and let's start talking about these two things here. We're going to scratch that off. PVC we're not going to do. HVAC, we're not going to talk about it. Getting into dust pipe, the different styles of dust piping itself. You have basically the different types you can put together. You have some of that are the spiral type pipes that you get together and you screw them together and then you tape around the outside or you seal around the outside. When you're working with those, they typically are a heavier wall and they can handle the negative pressure that's created by a dust system. And I've used those successfully in the past. But what you want to be aware of is that when you are joining the two pipes together, if I've got a pipe here and I've got a pipe here and I got a pipe here and I got a pipe here, they typically will have a sleeve that goes inside, goes like this. And that sleeve, we'll just draw that as a circle there. And then you'll put your screws through it, you put your screw through it on each side, and then you'll seal this from the outside. This connection, as the air is going through, is going to create turbulence. And like everything else, turbulence then reduces the pipe reduces the efficiency, and this will create little problems. In addition to that, every place that a screw comes through creates a snag point that it can pick up shavings, or if you're doing plastics for some reason and you're getting shavings like off of a scraper station for some reason, if the scrapings PVC should happen to go through the pipe from off of your edge banders, they can catch on this. And what you don't want is having any snag points inside your pipe. Okay, what that will do is it will catch particulates, and those particulates will start to build up until they can no longer hold on, and then they release. And when they release all at once, they go into your fan. And depending on what that is made of, the product that you're extracting, when it hits your fan, it can be destructive to your fan. I'm going to go back probably 25 years. I serviced a fan that was on a edge bander where they had the 3mm scrapings came off, turned into its rat's nest until it couldn't hold on any longer, and then got sucked into the fan and landed on one of the impeller blades and threw the fan out of balance and took the motor out. It was that far out of balance, and it just rattled a little bit. Nobody thought anything about it. They just ran. Next thing you know, the dust collector went out, and so they took out I don't know how much the dust collector cost at that point, but if memory served me right, it was $1,000 for me ish. We're talking 25 years ago, for me to come in, pull the motor out, take the motor off, get the motor serviced, put new bearings in it, bring it back, put everything back in. Fortunately, it did not damage anything other than bearings, so they got off very easy. But this is a downside to using spiral pipe. Again, if I was going to do it, what I would do is I would go into this, and before I assembled the pipe on the inward side, and I would go through and I would wrap this surface. See if I can clear this up just a little bit. What I would do is I would go into this surface and I would tape this surface off in here, so as the air come across, it had a nice transition. This is going to be down on the downwind side of it, so the turbulence isn't going to be bad, but this turbulence in here is going to be horrible. So if you can lay that off with some tape on the inside, some of that high quality metal tape, I think that will go a long way to helping you out. Then beyond that, when you get back into your spiral pipes, you got a huge selection of elbows, bends, branches, Ys, all the things that go into it. So it's a good system to get into if you're budget minded. The product is fairly cost effective and still be able to do it correctly. Okay, so backing up from there, the next selection that I would do would be the snap together units, and there's a company called Norfab. See if I can put them down here. Whenever we go into the shows, Norfab. Norfab is they snap together. They got these little couplings that go around and everything. It's very straightforward. You can't really screw it up as long as you follow the principles that goes through on how to put all this together. And then as your system grows, because hopefully as a company you grow and you don't stay static, you just disconnect all these fittings and it just all falls back apart down to its breakdown components, and off you go. You just rebuild the system into its new configuration. That is, for me, why I love this system. And there's several people that make this type of system, but offhand, Norfab comes to mind. I want to say there's another one called KNF or KF, something like that, and I think United Steel or United Piping or somebody like that. Anyway, there's several people that make that type of system. And it is more expensive, but in the end of it, you have that old saying that you can have it quick or you can have it good or you can have it cheap, but you can't have all three. That comes into play here. So you've got those factors that come into it. If you don't have a lot of money, the spiral pipe is good, but it's going to take you longer. If you are more time sensitive, the Norfab is going to come back in and the quick fittings, again, using this generically speaking. When you are assembling this pipe, the labor is significantly cheaper going in and assembling this, because you're not cutting a whole bunch of pieces, you're not screwing bunches of pieces, you're not going back and sealing anything together. It all just goes together like a great big Lego set, and it just works. And it's efficient. All the insides are smooth, the efficiency goes up, you have nothing protruding from the inside, so everything is great there. So there's a trade-off with it, okay? Beyond these two types of systems, the next step up is the welded system, and that's what you typically will see in the bigger plants, where they'll go in, they're not moving machines around every day, they're not moving stuff every 6 months, or, you know, for a small shop, if you go in and you add a machine and you have to go in and revamp a bunch of dust work, it's an expensive endeavor as far as the bottom line, what hits you in your pocket. With the big factories, they're less concerned about the cost to redesign the system than they are about the efficiency. So when you get into those welded pipes, the trunk lines and stuff like that, you can't beat them. I mean, that's just the way to go. It's beyond what I would ever do. I do not do any welding at all, mostly for insurance reasons. My insurance agent told me years ago, 0 welding, and it cut my insurances significantly. So I don't weld nothing. I can weld, but I don't. What we're going to talk about in this is we're basically going to talk about how to size pipe, how to lay the structure out, what you choose to use in these 3 scenarios up here. Let me get back over in these 3 scenarios, 1, 2, or 3. We're going to primarily worry about the dust pipe itself, not so much the HVAC and the PVCs, because I don't work with those. I don't recommend those. They're just wrong. Okay. As always, guys, be safe out there. We don't do anything that's worth going to the hospital for, so make sure that if you're up in the air that you got your fall protection, and that you're taking care of yourself, because, you know, we all got somebody we want to go home to. And as always, let's go make $1 million. Have a great night.